Oh, Chao Bui-san. Sorry, Chao Bui-san. Good morning. My name is Nobu Tabata from Japan. And secondly, thank you very much for giving my exercise from the first floor to here. Lots of steps. I feel I'm getting old. But a good exercise recently, so I didn't have the exercise. I got very good exercise. Today, I would like to have the. I have this presentation, and I'd like to share my information, also your information. Okay. And sorry, so I can't speak Vietnam language. I can speak only Japanese and a little bit English. If you need interpreter, so I can appoint someone to help me. So, really, yeah. So, yes, it's better to translate Vietnam language.
Yeah, I think in here all the engineers, yes. You can go ahead with the English, but some special technology work or something. I mean.
Okay. In this case, so I will explain in English, and if you need any assistance, don't hesitate and raise your hand and stop me. My colleagues can help to translate your language. And if you need explain in Japanese, let me know. I can tell. And if you need Korean, we have a special Korean guest here. And Chinese, we have. That's maritime languages. Okay, let's go. Turn off. This is the agenda of today. First, I'd like to introduce myself and workers. But Billy already explained about Henkel's history, and I will make it short. And market overview. As he mentioned, so you are engineer. Maybe every day you are focusing on the new design or new trend. I will show the trend of the electrical module, especially power module. If you have some question, I'd like to share, because I don't think this is perfect. I need to add your idea to make it better. And power segment, trend and drivers, and thermal solutions, thermal interface material, of our material, and conclusion and Q&A. And in my presentation, when I introduce a material, I'd like to demonstrate some other, show some our product. In this case, please come to here and let's touch and let's discuss. Okay, about the Henkel. When I come to here, I really enjoy Saigon beer. It's very nice. I cannot wait tonight, this evening. Anyway, so I joined this company, previous company is the Barclays. Barclays was acquired in 2014. And I came here this material. That time, so Barclays in Japan had only one people. It was me. And I was a kind of the CEO or sales manager, delivery man, and housekeeper. Well, I did everything by myself. And this is the territory the Billy already mentioned. That's I was here. And the second one is the market overview. I think some of you are in charge of the thermal management. And in the past, 2015, so main market is a consumer like a PC or something. But today or to 2021, main market would be automotive or industries. And devices is LED or PC, but moved to inverter or DC-DC or onboard charger or power module. And the customer to the customer's voice were critical to qualify. That is in the past, price. But still, price is one of the key factors. But most important thing is reliability. In the past, you have the issue of the thermal. Just to put something like a bandwidth. But today, you are going to design well organized. So before something happens, you already put the thermal interface material. That is the point is passive thermal solution to active thermal solution. And thermal interface material in the past had or grease to gap filler. Why gap filler? Later I will explain and I will demonstrate. This is also a market trend or total available market size. 2016, that's about 700 US dollar, million US dollar. 2020, that's a 2.6% growth, or 800 million US dollar. And in the pie chart, most of the growing area or by product, like a liquid and also a gap filler material. Why? Later I will explain more. Also, this is market overview of the growing. Most growing design needs power devices because power transistor provides a lot of heat. You should transfer the heat from somewhere to somewhere. You may know a lot of companies who provide the thermal. Some of them are your supplier. But in reality, Henkel and Workers still number one. We have been producing this kind of thermal interface solution more than 20 years. Again, I think you have to be concerned about reliability, not a price. Of course, price is important, but reliability is more important. Who is the longest experience? Who is a more reliable company? Please think about it. I am not saying Henkel Workers is number one. Each company has each strongest and weakness. But please think about it. Don't pick the unknown company by price. These companies, I can say, very reliable company. Please work with them. Also, don't work, that's my suggestion, don't work with big company. Big company is sometimes arrogant. Workers and Henkel is always listen to your voices. Later, I will show our product development. We never developed a material for the market. We always develop a material by the customer's voice. Who is the customer? Customer, lots of companies, but we don't recognize everyone is our customer. Our customer is our partner. Who is our partner? My management said and decided we have to work with our partner and we have to spend time with or for our partners. That is the reason why today, how many people came from Henkel? I flew from Japan, and he from Taiwan. He flew from Taiwan. Another guy from Singapore, and other two guys from Hanoi, maybe Hanoi, right? Just shake a hand to President Trump and Mr. Kim. And that's the reason why. So I really want to work with you. Okay, and just briefly, Billy already explained that this is our actual case history. Those staff provide a lot of heat. That's the reason why. So the customer needs the heat dissipation material. These are applications. Okay, this is the most important segment which I would like to share with you. This is our observation. There are 6 trends in power market. In the past, today, and future. These trends. Number 1 is power density. Power density means your power or your devices getting smaller and smaller. That is customer's requirement. And the output is higher and higher. The density must be higher and higher. Power per unit weight, that is customer needs to make it right for better efficiency. And relative cost, of course. It's getting lower and lower and lower. And relatively lost, how much power lost. And failure rate and time to market. This is those concerning. I would like to get your insight or idea. What is the most important thing? Please raise your hand. Please, 2 times. Okay? Not every time. What do you think? Number 1 is the most important thing. No? Second one. Please raise your hand. No? How about third one? One hand here. Okay. That's 1. 4. 5. 6. Okay. Thank you very much. Again, number 1. Don't hesitate. Number 1. Sorry, I don't have any gift. Oh, you have? Okay. Really, perhaps translate to add. Please, ask for that.
Okay, so you want to explain about the 6?
Yes, from these 1 to 6, and what is the most important thing they think? Number 1 is the most important. What do you think about?
Number 1 item about the power density. Tức là mọi người ok, trong cái tản nhiệt á, thì cái power density với lại cái reliability nó rất là quan trọng trong cái lĩnh vực đó, trong cái loại keo đó. Thì trong cái loại tản nhiệt á, thì nói chung là ngày càng ngày á, thì cái yêu cầu nó nhỏ lại, thì chính vậy cái density nó cần phải cao cấp hơn đó. Rồi xong rồi các power supply, cái công suất đi ra thì lại càng phải nhiều hơn nữa. Thì chính vì vậy mà cái power density nó rất là quan trọng trong đó, như là cái reliability, có nghĩa chẳng hạn như là anh yêu cầu CDQ specification như thế nào để đạt được cho tới mức đó, và combine rate là nhỏ lại và nhẹ hơn, không có nặng như xưa nữa. Đó là tất cả những cái là power density and reliability.
Em phải trả lời.
Which one is the most important? What do you think about? Number 1 is important.
Thế nào quan trọng?
Em phải trả lời.
Number 1. Okay. How about number 2?
It depends on the application. Depends
Okay.
on the things.
Okay. How about number 3? I think so you were facing, or you were receiving a lot of pressure of cost reduction every day from your customer.
I think this is just value for money, so it depends on the application also.
Yes. Okay.
For example, it is a high class, so we cannot use the cheap one.
Okay. Number 4. Oh, don't hesitate. You can speak local language or Japanese, please. 大丈夫. Number 5. Yes. Number 6.
So,
Leave time.
Dạ,
Okay.
đi tập.
So, that is our observation of power density. Many customers are thinking they need a better thermal material. Cost, of course. Those are very important. And then they are looking for better thermal performance material. In the cost, for example, not less cheap material. That is another way to assemble, like automation. And efficiency, of course, better thermal product. Reliability, yes. Time to market, thermal, and EMI. Today, so I will not introduce the EMI material, but we recognize EMI is the most important besides thermal material. If you are interested in, please let him know. We, as he mentioned, we are developing lots of EMI solution. And next, go to the thermal solutions. Just focus on the thermal solutions. Why? We need thermal solution. How to solve this issue? It's very simple. Today, I believe so. There are some thermal specialists. Please raise your hand if you believe so. You are thermal specialist. If you are thermal specialist, please come here and explain for me. I would like to learn. This is not kidding, because I learned from my customers. Today, I will explain about thermal. Most of the things, 90.90% comes from my customer. And they had an issue of thermal. And I learned a lot. And provide something. Sometimes it works, sometimes it didn't work. And lots of discussion. And sometimes I bring back his or her voice to our source plant and bring back to the new sample. That's during such kind of the catchball. I can tell about the thermal. Hopefully, I hope today I would like to bring your voices and bring to our source plant. Anything is okay. Please consider and make me busy. This is a very simple way of the thermal. How to transfer the thermal? This is only three ways. One is conduction. Second one is convection. Third one is radiation. Radiation is very simple. You can feel hot from the sunshine. That is radiation. And if you feel hot, you use a fan. And the window, the transfer heat, that is the convection. And you can feel hot, or when you touch the coffee cup, you feel hot, or cold coffee cup, you feel cool. That is convection. And this is a very much general speaking because of the design, depend on the design. But most of the heat go through by conduction. Let's say 80%. If we have the thermal issue, please think about how to transfer heat from heat provider to others. But total energy is not changed. That is a very simple physics. That's how to transfer and how to change to or to others. That is the flow. And mostly, most of the design of today, heat can go through the socket. In the past, not go to the socket, just go air or something. But today, lots of socket travel, heat travels through the socket. That is the reason why, so 20 years ago, so most of the thermal management was dealt by mechanical engineer, how to screw into the body or something. But today, most of the electrical engineer or circuit design engineer are dealing the thermal. Why so you need a transfer to thermal? Because this is a heat provider, like a socket, and this is a heat sink. If you watch the closely, it has air, because heat sink has a kind of the roughness on the backside, also some bending or tolerance. And the heat sink also has the roughness on the surface. It has air between the heat provider and heat sink. Air is a very, very bad heat transfer. When you feel cold, you can wear the jacket or a down jacket or something. A down jacket is a very good heat protector because of lots of air in it. Somehow, so you have to fill the gap by something and push air out. This is the purpose of thermal interface material. TIM stands for thermal interface material. What is the compost thermal interface material? It's very simple. This is not the one part. This is the 2 or 3 parts. Measure the polymer and fillers. Only filler can travel or transport heat. And air, say, it's very, very low thermal conductivity. The meaning of the thermal conductivity, or definition of the thermal conductivity is the kind of the speed of thermal, or thermal, that's energy, thermal flux. Thermal flux move to the some distance and the some area. That's kind of the speed. And solid. And the polymer is not so good. And aluminum oxide, hydride, and good, better and better and better. And at the end, diamond is the best one. Would you like to use a diamond thermal interface material?
No.
No, too expensive. Diamond must go to your girlfriend or your wife or ladies. That's, at the same time, so we have to consider price. And also, this is the Q is the heat flux go through this side to another side. And lambda means the thermal conductivity. And S means the effective contact area. And you can get thermal resistance. When I joined this market, or thermal solution market, people said, I need a higher thermal conductivity material. Please bring the 10 watt, please bring the 20 watt, 100 watt. But in real world, thermal conductivity is not so important. Most important thing is thermal impedance or thermal resistance. How to calculate the thermal resistance? This is very simple formulation. One example. We have 2.5 watt meter Kelvin to 10 watt meter Kelvin material. And this is the thermal performance, thermal resistance. And this is the bond line. When you press a certain pressure, reach this thickness. For example, 10 watt meter Kelvin material could reach 150 micron by some 50 psi. And 2.5 watt meter Kelvin material can reach the 20 micron. At the end, this is thermal resistance. Resistance is the same the thinking way of electrical resistance. Higher is worse. Smaller is better. You see, 10 watt meter Kelvin, 3.3 watt meter Kelvin. Which is better? Which one would you like to use it? For thermal solution, this one is much better. Because here, please remember this simple formulation. That's the reason why so I told you thermal conductivity is not equal of is not equal of thermal impedance. And how the where a thermal in real world in your design, how to design and how to minimize the thermal resistance. There are 3 areas to provide the thermal resistance. Number 1 is heat provider, between heat provider and thermal interface material. Second one is thermal interface itself. Third one is thermal heat sink, between heat sink and the thermal interface. Formulation or the same. This resistance here, here and here, this is one is the most important factor is contact area. Also here is the thickness and lambda, thermal conductivity. And this one is also here, contact area. This is one example. Which is better? Yes. This one is better. Even if the R2, R1, R0, R0, R1, R2, it's a big difference. R2 is R1 is the same, but at the end, this one shows the much lower thermal resistance or impedance. This is one of the examples. Henkel has the 2 watt meter Kelvin pad and 1.8 watt liquid material. Later I will demonstrate. And thermal resistance, which is lower here, because of better weather, the more effective contact area. This is a very simple technical way if you don't know about the thermal, because thermal cannot see. But you can imagine 2 vessels, the water flow, 2 vessels, and put water, and connected by pipe, and go to the next water, and exhausted. This is the you can control this volume? No, because that is already designed. Can you control? Sometimes by using the heat sink, but some height is already fixed. The most important thing is here. Tube resistance means thermal resistance. How to reduce this resistance? You can imagine the waterfall. That's the reason why I mentioned at the beginning. This volume is equal. How to transport the water smoothly? That is the most important way. Bigger, shorter, less resistance. That is the way, the technical way. This is really a useful way to think about imagine or image of the thermal flow. This is very special And also, I heard from my colleagues, so today, lots of engineers will join. That's the reason why so I showed this, the page. Okay, that is a very simple explanation of thermal why so we need a thermal and how to solve the thermal issue. And next is what kind of thermal interface material we have. I'd like to introduce. Again, our core technology is thermal conductive material. Based on your or customer's voices, we create a lot of things. Let's see. We have lots of products. Gap pad is like big gap material, and sheet pad is nothing. Get back to it. Sheet pad is a very thin material. So before this sheet pad, customer used thermal grease or mica. We had mica because you are Lucian. You don't know the mica. Mica is a kind of the mining material, kind of the stone. It's very thin but pressure. And when you screw it to break. And also, grease is very troublesome. It's sometimes dirty. And one day, one guy was thinking deeply, is there any new material or good material to solve the customer? Because customer was in trouble in the dirty thermal grease or very fragile or thermal mica. And he created sheet pad. Who created? That was Carl Marcus. That is the start of Marcus company. That's more than 25 years ago. And now, today, many people call that kind of pad or that kind of sheet pad. I was very surprised, so when I joined this company, many people said, oh, they are using a sheet pad, they are using a sheet pad, everybody uses a sheet pad. And then, what? They are using our material? No. Sumitomo sheet pad, Denka sheet pad, or Dow sheet pad. That is, sheet pad that is already registered, but they are using this kind of material. They call the sheet pad. And high flow is like this one. Okay, please.